Hello and welcome back. This is the final lesson in Module 1 dealing with finding another way of solving a linear system of equations. So remember that we've already talked about graphing the linear equations and looking for their point of intersection. We've also talked about substitution, where we plugged one equation into another equation, the other equation, once that first equation was solved for a variable. And we're also going to be looking at today at elimination, which is another helpful strategy. Neither of these strategies are great every time. So in other words, you'll really want to know all three of these methods because there's some problems that are easier with the different methods, with each method, okay? There's no one way that really is going to always work all the time. You know, you could maybe argue that graphing will do that for you, but truly each one of these has its own strengths and weaknesses. There's no like one that's always good all the time. So let's jump down here. Again, you should have your student copy of the lesson here, where we're going to be filling in some of the examples, okay? But first, we're going to scroll down here to the bottom where we talk about the lesson summary, okay? So systems of linear equations can be solved by eliminating, there's that idea that I just talked about, one of the variables from the system. One way to eliminate a variable is by setting both equations equal to the same variable and then writing the equations equal to each other. So that's substitution, right? Here we have a situation where we can set them both equal to each other and then just solve for x and then plug back in and solve for y. Okay? However, there's another way to do this too. Another way to eliminate a variable is by multiplying each term of an equation by the same constant to make an equivalent equation. Then use the equivalent equation to eliminate one of the variables and solve the system. So for example here, look at this system, okay? They are choosing here to multiply the second equation by -2 on both sides, right? So this second equation, we're going to multiply by -2. Why? Okay, so you can see there's the -2, there's that second equation, and you multiply it through and you get this new equation. So here's the new system, but it's still the same as the old system, right? We just rewrote that second equation, that's it. But it's still the same equation, just multiply both sides by -2. If you add these two equations together though, right? So we're going to add these, and add these. What happens? What happens to these x's? What's 2x plus -2x? Cancels, right? What's y plus -2y? Well, that's going to give us a -y. And what's 8 plus -20? Well, that's going to give us -12. And look at that. We eliminated the x's, and now we have this very simple equation to solve, right? What would you do to both sides to solve? Divide both sides by -1. And so we get y equals 12. And now that we have y equals 12, we can plug that y back in here or in here and solve for x to get the corresponding x value. Okay? So let's see this in practice here. All right, so we'll work through example 1. Now, if you look here at example 1, you can see what do we have here? What can cancel out? Look at your variables. Will 6x plus 2x cancel? No. But what about this -5y and the 5y? They are exact opposites. We can get those to cancel. So we'll add these two equations together here. 6 plus 2 makes 8. -5 plus 5 cancels. And then we have 21 plus -5, which is going to be 16. Wow, look at that. What do we need to do now to solve? There's no y here, so we can just solve for x. Divide both sides by 8. And x is 2. We're not quite done, though, because we also need to come up with a y coordinate. All right, we can already see we're going to have one solution because we got an x value here. But let's go ahead and plug this x value in to either here or to here. I'll use the bottom equation. If you chose to use the top equation, you'd still get the same answer too, just slightly different work. So 2 times 2 is 4. Okay, why don't you guys go ahead and solve from here. Pause the video, solve it the rest of the way, see if you can do it. Okay, hopefully you pause the video. So we'll cancel those out. And we get -9, divide both sides by 5. And we get y equals -9/5. Yuck. Okay, you can see this would be very hard to determine if you were graphing, right? So you can see why this method is important, because it allows us to identify, things that will be fractions, hard to see on a graph. All right, in the next video, I'll do 2 more examples for you. So, see you then.